Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my product development series. We are back working on the DIY water jet. I was able to go back to university and grab my my pump. So now I do have my pump and my cutting head. So again, this is the AccuStream A2 cutting head with a 20 thou or with a 20 thou tungsten carbide hole. Man, this hole is so small. This thing's gonna be pretty awesome. And it's already loaded in the collet, and this guy's already tightened down here to hold on to it. So all of that is already done. And I believe it's already pushed all the way up. Yes, and then the threads on this are so nice. This is how you do threads. Threads on this are amazing because I think it's got some Loctite, some blue Loctite, and already the mixing tube is already pressed all the way in. So all together, my mixing tube, use even the caliper. So from the point of attachment to the end of the mixing tube is 4.5 inches. So that's from the top of the taper down to the mixing tube. And it looks like I'm going to need to have some sort of seal in here. And then I have my orifice. So let's go ahead. So basically what I'm doing here is I'm looking at, I talked to Tim again from Little Hawk or whatever the company's name is. I forgot what exactly the company's name is. But, so yeah, here I have my ruby orifice with a 6 thou hole in it. So small of a hole. Barely even see it. So you just kind of drop this guy in there. Shake it around. And then it goes in the hole just like that. So it looks like basically what's going to happen is I have a little face in here that I have to seal on. That's pretty much what it looks like. So I need to go in there and seal on that face. Yeah, so go in there, seal on the face. So I have a face there. So I'm going to have to show that to Tim, as that's what I have to seal on. So things are going to probably be a little bit different on his side. And then we have two garnet tubes. One... Oh, actually they're lined. Are they lined with tungsten carbide? They're lined with something. Oh. This has got something in there. Oh, it's just got a piece of fuzz. Yeah, all this stuff needs to be cleaned out because I remember there was a burr on one of these ones somewhere. There was a small little burr. And these tubes on the outside are going to be the same tubes that we use on the hopper. These are 1/4 inch tubes. So these are 1/4 inch OD tubing that we need to attach to this cutter for the garnet to supply the garnet. We have two sides. One side sucks in. I think the other side we got a cap, I'm pretty sure. And so this theoretically seals. And then this guy sucks garnet in and down, I believe. But then again, we can pull that piece off whenever we need to. So yeah, so orifice is in there. Let me take the orifice out. So yeah, it does look like that we need to seal there. And then I don't know if we need to seal on top of the orifice. But... And the orifice sits in there so tight that I basically had to bump it up against my arm, bump it up against my hand to get it to pop out. So there's that, and now, so again, it was 6 inches from top to bottom, so let's go ahead and go into the Trello and water jet cutter. And so here, measured features. So here, A2 AccuStream cutting head, top of thread to end of mixing tube is 6 inches, right? And I need to get a new battery for these calipers. I have these composite calipers that are plus that are 10 thou accuracy. Oh no, it was 4.5 inches. It's like 4.55 inches, about 4.55 inches. And yeah, and then we have this mounting location, which is, so we have this hex. Is it a hex? 1, 2, 3, 4, 5, 6. 6 sides. So it's not a hex. It's a pentagon. What is it? Pentagon. I think it's pentagon, I think. Just like the actual pentagon. Pentagon 1, 2, 3, 4. Yeah, should be pentagon, which is 6. Anyways, so the point where it's going to mount is actually a V shape. So we might need to print a piece that goes around that, because and it's not sitting on a flat; it's sitting on a V. And then we have a little bit of clearance, and it basically has this bowl shape, and that's where it expands. So the volume opens up, and pressure drops, and it sucks in garnet right there. It has this V. Let me go ahead and show you. Cutting heads. So yeah, so basically if you look here, oh, what the heck? That's not actually how it's machined. That's strange. Because if you're looking at it on mine, this bump is in line with this down. Not how it has it here, so that's very strange why they would do that. So basically I have this ridge that's down here, and so that guy needs to be lined up, and then it has to clear this bump right here, right? And then probably a 3D printed piece to go over this so that it holds this guy on, and then clears that piece. And this thing is heavy. Do I have my scale up here? I do not. I'll have to bring my scale. My scale's 500 grams. This thing probably weighs a pound. This is not light. Again, this is all stainless here. Pretty much 100% stainless. And then we're going to have that hosing coming off. I'm pretty glad now that we're using the Core XY, because we're definitely going to need, for high speed cutting, for thin stuff, we're definitely going to need that, the power of both motors. Yeah, anyways, otherwise very, very nice cutting head, super heavy, like I said. I'll probably, before the end of this video, I'll go grab the scale and we'll look at how much our gantry is going to weigh, because pretty much this is going to make up, I'm going to say, 90% of our gantry weight. But everything here, everything that's needed is here. Now I just need to get the engineering done on how this guy fits in there. And again, I have a couple things that I got to get them. I got to get them the depth of this counter bore in here that we have to seal up against. But there is a little pocket right here. There is a hole right here. So I'm wondering why there's a hole. There's a hole like right here. Right? And then there's another hole which holds a pin which is right here. And again, this ridge is right here. But that pin, I know what that pin is. If you look inside, it's actually where the mixing tube bottoms out. Right, so that helps set the mixing tube. Okay, so that looks good. Again, I would really like to get the scale. This might even outweigh my scale, because that scale is only, it's very high resolution, but it's about a pound. Okay, and then I have my pump. And now on the inside of my pump, it's the 7/8 connection. Actually, no, this is 15 by 1.5. So Tim's looking if they have that. And it looks like I have, ooh, this, so this is the high pressure side? Yeah, it is. So it does indeed have a taper. So it does indeed have a 60 taper, and it does also have possibility for a face seal. So it does have a taper and a face seal here. Oh yeah, so that's definitely indeed a taper. So we should be okay. If that's 60 degrees, we should be okay to seal up by pressing the nut in there. And the threads go all the way down, pretty much. So because the threads go all the way down, we could have it go all the way down and butt up to it. So that looks good, but the hole is tiny. It's like an 1/8 inch hole, right? And the thing's the thing's a 14 millimeter thread. And then on the other side, the inside, which is, it's got a tiny little hole. But this one's got no taper. It doesn't even look countersunk. But then again, there's only 60 psi of pressure here, so then just using Teflon tape should seal that up. So, and then it comes with these little red silicone boots to put in there to hold it. And then the other thing is what exactly fits inside of this pressure line. So they also have a silencer, plastic silencer, that I put on here. And then they have a little piece that goes here that the air goes in. And then same thing here, just Teflon, because 60 psi, no problem. And this is cast iron. And then they have another little nut up here, and then this is for the silencer, I'm pretty sure. So yeah, so I think we're going to be good on the pump side. Now the cutting head side, that's a different story. Cutting side, we're going to have to do some special sealant, where it's got to have a face seal with an O-ring. And even here on the outside, the surface finish on the inside here is really, really bad. So surface finish on the face is really, really bad. So if I put an O-ring there, it'll probably leak. So I think the 60 degree looks okay. The finish looks okay. So I think we'll be okay there if we clamped it down hard enough and hope for the best. So I think with this on the pump side we'll be okay. Big old heavy pump. And again, this pump is probably 10-15 pounds. And again, I probably got ripped off as far as the shipping, and some of the parts on here have really, really bad surface finish for some reason, and some of these things are a little dinged up when it came in, but it should run for my purpose, and then maybe I'll get something in the States, manufactured in the States later on when this guy needs some new seals. And obviously, eventually, I'm going to go with direct drive instead of pneumatic, so that I could save a lot of efficiency. And then all I have to do there is have some sort of maybe like some sort of disengage that just allows the that allows the motor just to disengage pressure and just unwind and let all the pressure go, so the pressure just drops. But at that point, that's probably when I have to control the high side, and that's when a lot of cost incurs. So I'll probably, at that point, I'll probably have to build that on the side at the same time that I'm running the machine with this pump. But this pump's got pretty cheap seals, but the main thing is saving on electricity, because eventually that will pay for the new pump. But the new pump will probably be $1,500, $1,000 to make that pump. While this thing, I think, has $100 seals in it or something. It's $100 to do maintenance on this guy. And overall, I mean, pretty good. This is a Julyr, Julyr. But it just says July. It's a 400 to 1, not a 500 to 1. Right, so actually I remember now. It was 2,500 psi, not 3,000. But it really depends. It says, warning, do not use air source pressure more than 8.3 bar. So what is 8.3 bar? Sorry, not a whole lot going on in this video, but we are going to go in and do 8.3 bar. It's 120 psi. That's 120 psi, so that times 400. That's 48,000, but that exceeds the pressure of my hose. And also having a compressor that powerful to pump that high of 120 all time is very unlikely and extremely hot. Will run extremely hot. And then basically what I'll have to do, maybe run some of this water back over to the compressor, keep the compressor cold. So now also another thing that we wanted to check is for the manifold is what is the distance between the inlet and outlet, the two inlets and the two outlets to each other. So let's break out the tape measure. It looks to be approximately 10 inches. 10 inches on this side. Inches on that side. So let's say approximately 10 inches. So what we can do there we go. Now that is the right shape, about. And then remember they have about 1/8 of an inch hole, so that's a good question. Now if I bring this over here and look at the question is with that gland nut, .60 1/4 inch. Okay, so it's 1/4 inch. So that definitely fit in there. I'm sure that that's definitely not 1/4 inch, about 1/8 of an inch hole. But the question is how big is the hole in there? Is that 1/8 of an inch hole? Because obviously, I mean, it tapers down to about 1/8 of an inch hole. So it might be a 1/4 inch diameter, but 1/8 of an inch hole at the end. If that's the case, then it would fit perfectly in there, which is ideal. So I think that we are in good shape here. Everything's kind of coming together. So basically what I'm talking about is that this guy here needs to fit inside of that hole. And I'll see if I could contact these July guys and get a model for this so that we could move forward. But it does look like they added the 60 degree so that we could bottom out on it. And it's probably millimeters, but it looks around 1/8 of an inch hole. But taper, it might be more extreme than 60. Might be a 45. We'll have to see. Yeah. I'm not too, so it could possibly leak, so we'll see. Well, the other thing is that this is a 9x16. This is the right side. 1/4 inch tube, 1/4 inch tube. 1/4 inch by 28. This is left-hand thread. Goes on there, and I talked to him this morning, told him to look out on his email for some drawings this next week, and I'll make some drawings in the manifold. Now the manifold is pretty accurate to lengths here, so I can get a quote on this, and it is indeed 60 degrees, so this should be fine. And then this is the 9/16, 9/16, 9/16. 9/16 thread, 9/16 thread, but this has to be M14 box. Where'd it go? I think it's down further here. Oh, here it is. Oh, M14. M14 by 1.5. I thought it was M15, so I think M15 is not a popular fitting. So M14 by 1.5 is supposed to be the fitting size for this. So this is going to have and then it's got to go in there and touch. So what I have to do is I have to get them the depth to the face, and then see if I could stick a caliper in there and get kind of an idea on how deep that hole is in there. Maybe stick an 1/8 inch something, or put a 60 degree on something and shove it in there and see how far down it will go. But this is kind of the manifold here, and then maybe because I have the pump, I might be able to model it. I was gonna say maybe scan it, but it's too big in diameter. One of my friends has a scanner, and it's pretty good, so maybe be able to scan it. I think it's too big in diameter to scan and too heavy for the carousel on it anyways. So yeah, I like that. So save that. So that looks good. Now that we got all that stuff figured out. So again, the issue with the cutting head is that basically we just have this face in here, and the face is very, very small to seal on. And then we have the ruby on the inside, but the ruby, I don't think that you're supposed to seal on that, but that's kind of what it looks like it's trying to do. So maybe we could have some sort of negative angle and then go down and seal on that ruby. I'm pretty sure that's what they want you to do. It's not seal on this face, but seal on the ruby. Because then it could pop the ruby up, and then the ruby might not seal. I don't know how well that ruby's going to seal, because it's just stainless. It's just a piece of stainless, and there's no O-ring or anything on here. It's just straight corners, and it's got a tiny little hole in the bottom, even smaller hole at the top, and it's tapered at the top. There's got to be a reason why it's tapered at the top. It's got to be because something goes in there and seals on it. So maybe I have to talk to AccuStream on Monday to see if I could talk to them about how they seal on this thing. And maybe also if they have something off the shelf. If they have some sort of off the shelf solution that will mount to this thing and have a 9/16 come out the other end. Right? That doesn't have. I mean, it's basically that case. It's an adapter, right? But yeah. And then remember that our system has a 7-inch turn radius, bend radius now. So that's 14 inches. That's a big bend radius. If we look at my tape measure, which is over there, 14 inches is a long way. So let's put the cutting head away. 14 inches. That's a big turn radius. So that thing is going to have to clear way over the top of the printer. Hey, what are you doing? Stop that. She's chewing on one of my hats over here. So I do think that we might need to go with the 90 at the top just to get it to come in. So it doesn't have to do a full 90. Stop that. So it doesn't have to do a full 90 before it goes into the cutting head. And then here it's going to feed it straight up. So it goes straight up and goes into the cutting head at a 90. And also he said that they would be okay making a custom one where they just make it shorter. And that might be able to cut down on the cost. Because he says basically all the stuff that they do is custom. Which, I'm not a big fan of custom. If it's off the shelf, I'd rather do it off the shelf. But, hey, that's what happens. So, because again, for the longer one, they want about $400. Almost as much as the hosing. So, and also now they're going to have to change it. Because pretty much that gland nut's not going to work. Right? On the pump side it'll work. If they have M14 by 1.5, that'll work. But on the other side, that design's not going to work anyways. So you need to figure out some way. But then again, because at the end of the day, the 14.5 psi, the 30,000 psi that we're doing, it's not really feeling that kind of pressure because there's always a way for it to get out. We don't have a high side gate or anything like that, so there's nothing preventing the water from escaping on the cutting side. So there's always a low pressure side that it could get out on, and all we're doing to controlling it is at some point when we want to stop, we're removing the pressure generation instead of just clamping down on the pressure and just reaching equilibrium where we're reaching max pressure and it just stops. We're basically removing the air pressure. So obviously we're going to have a little bit of we're probably going to have a longer lead in because we have to build the pressure back up before we start spraying. So maybe with that, what we're going to have to do is after... No, we can't even stop. So yeah, we're going to have a weird thing where we have to start and stop on with a very long lead in, probably have a lot of splashing going on. So we're probably going to have to put a cover on there, and it's probably going to splash a lot of garnet everywhere because the garnet tends to get stuck sitting on the top of the material. Well, if it's bubbling the water up and over the material, but that's if you have the water too high. So, alright, so let's see if we can find some 7/8 or M14 by 1.5 barb fitting. Ooh. Aw. Female to barb hose. Wait, what was that? There it is right there. Easy peasy. And AM14 by 1.5 barb fitting, 1/2 inch hose ID. 1/2 inch, it's got a tiny little hole in there. It doesn't really need to be 1/2 inch, but I do like use. Oh, this is for a different project. That's a little too far extension for me, but it's got an O-ring on it. Guess the O-ring would work. O-ring's fine. It's not bad. $12. Oh man. What the heck is this? Oh, it's a elbow pressure adapter thing. So this might work. So add to cart. It's aluminum. Yeah, I might strip the threads off, but then again it'll dump some heat to that thing and cool it down a little bit, so that's nice. Some of these are fine too, by 5/16. 5/16 good size. Turbo water cool and banjo fitting. 1/2 inch. 1/2 inch plastic. Oh, anodized aluminum. Oh. It's M18. That's not gonna work. It's 3/8. 3/8 is a little better. 5/16 would be nice. I mean, it doesn't really matter. If I have to do 1/2 inch, I have to do 1/2 inch. This is another good one too. $13 is expensive. Oh, here we go. Oh, this is the prime one. Oh, it's an M16. Not even gonna work anyways. Okay, so this guy, and then for example, not this guy, but this guy. That's fine. Oh, there's nothing to tighten it down. What happened? There's nothing to tighten it down. What a dummy. Anyways, this looks nice. Oh, this is a 3/8, but they wanted $4 more for it. 1/2 inch is fine. I guess the bigger it is, the slower the flow rate and the higher the pressure. I'll have to look at it, but that's kind of the idea. That would be nice. So 1/2 inch. So now let's add this to cart also, and let's look at 0.5 inch T barb fitting. There we go. 1/2 inch. Okay, so some brass, get a whole bunch. Stainless steel. There you go, right there. Splicer fitting, T, 1/2 inch by 1/2 inch by 1/2 inch. T-hose barbed. Add to cart, $7. I like it. Easy peasy. Yeah, easy. There's another one. Pretty much the same thing. So now we have our low side. So our low side, M14 by 1.5, and then we have another M14 by this is a 1/2 inch T. So one inlet goes to the 2 outlets and then goes up to here using 1/2 inch hosing. And then I find some 1/2 inch hosing, and then we got to work on the high side. The high side's a little bit more complicating because of the issues of possible leaking. I think on the low side we just put some Teflon tape in there and we should be okay. So we've found everything that we need for low side. We're going to have to do some engineering that I'll talk to you guys about on what I learned about setting up the high side with this issue with the cutting head, and how we're going to get the manifold done. I think the manifold is going to be the easier part. This cutting head is going to be the harder part on figuring out how we're going to basically seal around the orifice, because this is definitely not 60 degrees. This is like 45 degrees. So it's like 45 degrees it looks like. So we'll see if that's the case, or if we seal around this little lip here. We'll find out. We'll talk to an engineer at AccuStream and then relay that information to Tim, and then also see if you know, because I'm getting more stuff done there, if I can get a little bit of a break on price. All right, so that's pretty much it this week for the water jet stuff. It's definitely progressing. I'm gonna talk to China and tell them that I'm still interested in that machine itself. But Tim said that with this stuff, if it's custom, we have 4-week lead time. So we need to watch that as well. So, alright, so this has been Steven from Legit Tech Tutorials and the Green Engineers, and stay tuned for this weekend. We are back on Zombie Alamo. I've got it all figured out. And also Ava's game. I'll be doing a lot of videos this weekend catching up on Zombie Alamo, because I've skipped a couple weeks trying to figure out how I'm going to do it. And so I want to catch back up with that. So stay tuned this weekend. A lot of stuff going on. And also doing stuff for other channels. So stay tuned. And I will see you guys in the next video. Take it easy. Peace.